Hi and welcome back. In this video, we're going to finish our milestone project by including the update and delete statements. We've added the create book table, which creates our table if it doesn't exist already. We've inserted a new book into our table, and we've also looked at selecting all of the books from our table and returning them as dictionaries. Now, we've got two more functions, mark book as read and delete book. With our files, what these did was read the entire file, find the appropriate book, update it, and then save all the books back. With SQL, we can actually find the correct book by name on the database and update it in place, so we no longer need to get all the books, change one, and then save them all back. For that reason, I'm going to delete this save all books function, and that's a good reason why it had the underscore in the beginning. It was something that we wanted to use internally to make our interface work, but it wasn't something we wanted the app use. So that's why I had the underscore before to mark it as sort of private, so that other parts of our program wouldn't want to use it too. To mark a book as read, you know how to do this now, because we have to initialize a connection, get a cursor, execute our update statement with a where clause that would where by the name, and then commit and close the connection. We don't even need to return anything or get any data out of the database in order to do this. I think you can implement this function on your own, so give it a go. I'm sure you managed to do that. We've just looked at the update, and all we have to do is again copy this boilerplate SQLite3.connect to data.db. Make sure to use the correct data file, get a cursor, then execute our SQL, and this is going to be update the books table, set the read to 1, where the name is equal to a question mark. Remember, you must not use f strings here, because that opens you up for potential SQL injection attacks. So what we're going to put here is a tuple of name. And notice that in order to make a tuple, we have to include the brackets, as well as the comma, in order to say this is a tuple. It's not a mathematical thing that we want to evaluate first. And certainly, if you don't put the brackets in and you just do this, it thinks that this is an entirely new argument to the execute method, which we don't want to do. We want to make sure it's a tuple, so we do it like this. Now that we've ran this, we want to make sure that these changes get saved to disk. So connection.commit, and finally connection.close. And that's it. Now we've updated our book, set the read flag to 1, where the name was equal to name. Going over to delete book, I think you can also implement this. For what we have to do is pretty much the same. Once again, pause the video and give this a go. Now, I'm sure you really managed to get this. What I'm going to do is copy this boilerplate, not something you should be doing very often. But instead of updating, we're going to say delete from books, where the name is this question mark. And once again, the name gets passed in as an argument there. Then we commit once again, and we close. We don't have to fetch any rows or anything, because there's nothing for us to return from this delete statement. And that's it. We've got all the data in and out of our database that we needed. We can go back to app.py, and all we have to do is potentially update this book read flag here. We could say yes if the book's read status is true, otherwise no. But what you didn't know is that if 0 actually evaluates to false, and if 1 evaluates to true. So if book read is 1, contains the integer 1, we're going to get yes. If it contains the integer 0, we're going to get no. So we don't actually have to change this at all. Python automatically treats 1 and 0 as true and false as well, which is pretty handy. So we don't actually have to make any changes at all to our app.py, which tells us that we've done an excellent job isolating our data storage device, our database, from our business logic. And I keep going on and on about this interface. because it's really important part of programming to be able to decouple your different components and make sure that they can operate without knowing how the other one is implemented. That's really important. Let's go ahead and run our app. And then we can look at adding a new book. Oh, and we get an error. We get an error that says, integrity error, unique constraint failed on books.name. That means that a book with this name already existed in our database. Interesting error. Of course, we know that this should be an error. We don't want the same book twice. So what happened is that our data.db was existing from the last time we ran this and I entered the same book. So if you want to get rid of this error just temporarily, delete data.db and run your app again. Then you can enter clean code. Then you can list all your books now, and that gives you clean code by Robert C. Martin. You can, of course, mark a book as read. Then you can list the books again, and it gives you clean code by Robert C. Martin. You can delete a book. Not that you'd want to delete this book. And then you get nothing when you list the books back again. So we've made our program work with a database, a SQLite database, which is very, very similar to a Postgres or a MySQL database. The way we interact with it using SQL is pretty much the same. Postgres and MySQL are more powerful. They do more things for you. And they also have a bit more functionality, more different types of data you can store, and so forth. But really, what we've covered is the same amongst all major databases, which is really cool. Of course, we haven't gotten rid of the insert error when we insert something that already exists, but you could do that. You could put a try except here on a integrity error and just print out something that says we can put out your book, or you can return false potentially, and then in your app.py say if this succeeded, print nothing, and if it didn't succeed, print you've already got that book in your database. Feel free to extend this as far as you want, and of course ask questions in the course Q&A if you encounter any issues. We'll be happy to help you. I'm not going to bore you any longer with continuing with this project. We can move on to better things. So with that said, I'll see you on the next video. We're going to talk briefly about one more thing in SQL that we didn't get to use in this project, but still pretty important, and then we can go over to the following section. I'll see you soon.